we'll see that to find the equation of a periodic function from the graph or a sketch below. You can see that this is the graph of either of sine or cosine. It doesn't matter, but this is definitely not of tangent. This graph is not a tangent graph anyway. So in this case, by observation, you have to see the graph, and then from this graph or a sketch, you have to find what is the periodic equation. Okay, you can see in the scaling first of all here. So it is 2, 4 means 2 units equals to 1, another 2 units, this is 2, then this is 3, then this is 4, then 5 in between 4 and 6. So this way, so first of all, you have to understand how the scales are given there. And along the y-axis also you can see this is 0 and 2, so 2 units is 1, because here 4 units is 2, that means this is 1 and 2, in between 4 and 2 it is 3, and like this. So you have to see this gap. So 1 square unit equals to half, and the 2 square unit is 2 along both the axes. Okay, so first of all, in order to find the graph of this, so I'm assuming this is the graph of cosine function. So in general, I will consider one equation like this: y equals to a cos bx plus c and plus d. So here the translation along y-axis is represented by d. So if you get the values of a, b, c, and d from this graph, then you will have the periodic equation for this graph. So if you think of this, a is the amplitude and b is the translation of the graph along y-axis, either upside or downward of this x-axis. So you know that a can be found by using, if you would like to find a, then a will be given by y maximum minus y minimum and divided by 2. So y maximum is, you can see here the y maximum value is at 6. Okay, from here to here this is 6, so that is 6, and the y minimum value is here. So can you see this is y minimum is 2 here, so this is 2, and then it is divided by 2, so it is 4 divided 6 minus 2 is 4, divided by 2 is 2. So we have the value of a. Now what do you think about value of b and c? We'll see later. So first of all, let's see the value of d. So d will be given by d equals to, you can see that d means y maximum by plus y minimum divided by 2. So it is y maximum is 6 here, or you can see from the graph from here also you can see this is 6 because it is at 6, y equal to 6, and then plus y minimum is 2 again and divided by 2, so 8 by 2 is 4. So we have already the values of a and d. So let's note down your value of a is 2, and the value of b is, value of d is 4. Okay, now let's think of period. Now what is the period of this graph? Period means b times x is going to be bx. So you know that period is equals to period of cos or sine is 2 pi, but here we are talking of cos bx. So therefore the period for cos bx will be equal to 2 pi by b. All right, now that is you can say that in general the period of this graph is 2 pi by b. Now let's see what is the period over here. So period means, if you are assuming this to be the cosine graph, so period means the distance between maximum to another maximum or minimum to another minimum. So here maximum points are obvious, so we take the reference of maximum point only. So here you can see that this is about 1, x equals to 1, so x equals to 1 over here. And here if you count, this is maximum at here, x equals to 13, and length between these 2 points will be the period of the graph. So period in this case is, how many counts here? From 1 to 13 is 13 minus 1, you can say, or just you count it, and then 13 minus 1 will be 12. That means period in this case is 12 equals to 2 pi by b, and therefore value of b is 2 pi over 12, that is 2 6 are 12, that means it is pi by 6. So we now have the value of d is here and value of b also of level. So value of b we have got is, it is pi by 6. So we have all these values of level. Now we have to see that what should be the value of c actually. So if you are considering this as cos, okay, so cos has maximum value at x equals to 0, okay, 0 degree. So x is 0 point here. That means what happens here, it would be, if this point would be over here, then this graph looks like as if it is shifted 1 unit right about this y-axis. So 1 unit right about that y-axis means, by the law of transformation, we know that the value of c must be -1. It's okay. Why -1? Because it has shifted 1 unit to the right. If it would have shifted 1 unit left, to make it exactly the cosine curve position at x equal to 0 degrees, in that case we write +1, but it is from this origin point, this sort of maximum point has been shifted 1 unit right. Therefore for 1 unit right we write -1. For 1 unit left, if it would be, we write +1 by the rule of transformation of graph along x-axis. So we now have available the value of c also. So value of c, we have now c equals to -1. So therefore this equation will become now y equals to a, value is 2, and cos b value is pi by 6, and in the bracket this is x, and c value is -1, and plus d value, you can see here d value is 4. Yes. So from the graph we saw that this is one of the equation for this curve. Okay, so it is 2 cos pi by 6 x minus 1 plus 4. Therefore, if you consider this graph to be of cosine function, the equation of our periodic function is like this. What if you consider that to be sine function? Sine function. So you know that the maximum of cosine occurs at x equal to 0, but maximum of sine occurs at x equals to pi by 2. So if you suppose this as the sine function, then in that case, what you have actually, you can see here, this is one step and this is another step, so that the graph looks like as if it was like this before. And like this before, and it has now been shifted 1 and 2 units left. So if you consider this to be the sine graph, what would be our equation? It is y equals to 2 cos, no, y equals to 2 sine pi by 6. So here x minus 1 for cos, because it has shifted one step right. But here this graph, if you consider that to be sine, so sine has value 0 at 0 degree. So this is about 0 degree over here. So therefore the sine seems to shift. How many steps left? It is 1 and 2 steps left. Therefore we can write, instead of x minus 1 for cos, but for sine here we can write x plus 2, because there is 2 units shift towards along 2 units shift towards left along x-axis. So it is plus 2 and plus 4. Here you saw that from transition from cosine to sine, there is change in only x, okay, but not in the amplitude, and also in the translation along y-axis. Okay, so that is the same thing. So we have the two equations from the same graph. So let's check whether or not these two equations give the same graph like this. So in the Desmos graph, let's go over there. Let's now check whether or not the same graph has both these periodic equations. So in order to check it, this is good idea that to go to the Desmos graph. So in the Desmos graph, let's see. So we have the same two equations, and you can see that for the cosine graph, we have graph like this, and also for the sine graph, we have the same graph. That means both these equations are appropriate equation or the correct equation for this given graph or a sketch.